In this video, I will show you how to calculate the voltage stored in a capacitor when they are connected in series. Let's say I have three capacitors C1, C2, C3. See, they are connected in series and I am supplying their series connection with a voltage of V. As they are connected in series, the charging current I will be same all over the circuit and the voltage V will divide. Let's say the voltage stored in the capacitor C1 is V1. The voltage stored across the capacitor C2 is voltage V2. The voltage stored in the capacitor C3 is voltage V3. Okay. Now, to calculate the voltage stored in each of the capacitors, at first I have to know the equivalent capacitance with respect to this terminal and this terminal. I will calculate equivalent capacitance of this circuit C equivalent. See, as the capacitances are connected in series, therefore we will calculate the equivalent capacitance by using this formula. 1 by C EQ will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. Once we know the value of equivalent capacitance, after that we will use voltage divider rule to calculate the voltage stored in each of the capacitor connected in series. So let's say at first I am calculating the voltage V1 that is stored in the capacitor C1. I will take C equivalent divided by C1 into the supplied voltage V. If I want to calculate V2, I will take C equivalent divided by corresponding capacitance into supplied voltage V. If I want to calculate V3, I will take C equivalent divided by corresponding capacitance into voltage. This is how we calculate the voltage drop across each of the capacitor. Now see, if I want to calculate the voltage across nth capacitor Vn, I will take the value of equivalent capacitance of that circuit. After that I will divide that equivalent capacitance with corresponding capacitance Cn and multiply that with total applied voltage V, and this is the voltage divider rule in case of capacitors connected in series. Now we can deduce a special case when we have two capacitors C1 and C2 connected in series. Let's say the voltage across the C1 is V1, the voltage across the C2 is V2. I am applying a voltage V across this terminal to this terminal. Now see, with respect to this terminal to this terminal, our equivalent capacitance will be equal to 1 by C equivalent will be equal to 1 by C1 plus 1 by C2. Here if I write it like this, C1 into C2, I am taking the LCM, from which I can calculate our C equivalent will be equal to C1 into C2 divided by C1 plus C2. Okay, now if I want to calculate the voltage V1, I will take C equivalent divided by corresponding capacitance C1 into applied voltage. Here our C equivalent is given by C1 into C2 divided by C1 plus C2. In the denominator I will get C1 and I will multiply this fraction with V. See, this C1 and this C1 will get cancelled. Therefore here I will get C2 divided by C1 plus C2 into V. Now if I want to calculate the voltage stored in the capacitor C2, that is V2, I will take C equivalent divided by C2 into V. Similarly, I can calculate C1 C2 divided by C1 plus C2 divided by C2 into V. See, this C2 and this C2 will get cancelled. Therefore, here I will get C1 divided by C1 plus C2 into V. See, when we have two capacitors in series, when I will calculate the voltage stored in the capacitor 1, I will take the capacitance of other capacitance divided by the sum of both capacitances, C2 divided by C1 plus C2, and I will multiply that fraction with V. And when I will calculate the voltage stored in the capacitor C2, I will take the capacitance of C1 and divide that with the sum of C1 and C2, C1 divided by C1 plus C2, and multiply that fraction with V. So this is the voltage divider rule for the capacitors when they are connected in series.